because given any variable, if I can say given a function f of a given by a squared plus 2a, I can ask you to evaluate any I can check a to be taking any values as long as the a and the a is in the domain. For this case, when you look at g of a equal to a squared plus 2a, a can be anything. A can be any positive number, it can be any negative number. So which means that the domain is the set of real numbers. So from negative infinity to positive infinity. That's why I've been popping in values like -2, 2, -1, 0, 1, and 4, and -4, and so on and so forth, right? So which means that you can put any input, any real number can be an input, and then your output will be again another real number. So the domain is a set of all real numbers, and the range is a set of odd numbers. That's all I wanted to say. If you evaluate you try to compute g of 2 until g of -4, you'll find that you get different numbers. Can be positive, it can be negative, it can be even a zero, and then those numbers belong to the set of real numbers. So which means that you can pop in any number, it will still, the output will also be a number. So that means that the range is the set of all real numbers, and the domain is also the set of all real numbers in those instances. However, uh, we can twist it from the last time what we did. We can twist it slightly more, and then when we put the square root, then we'll see that the range might keep some of what do you call some of the info, but the domain, I mean, the domain might keep some of the info based on the restriction, and the range might change it generally to either from 0 to infinity or something like that, generally, more or less. Now, the most common point last time you asked, some of the students asked, was that why do you see one of the property, if let's say for the one I gave you g of a equal to, let's say, I can't remember, a squared plus 2a. If I ask you to factorize, it's just going to be a times a plus 2, right? So yes, it's part of these things. Why we give mark for the factorization? Because we need those when we try to, let's say, when we try to solve, or when we try to sketch the graph of the function g, right? For you to sketch the graph, there are, let's say, there are several possibilities. I can literally ask you to say solve, because I can see that this is very easy. For you to sketch the graph, you have something called intercept that you must always need to figure out. Intercept is x-intercept is when y is 0, and y-intercept is when x is 0. So to sketch a graph, you need a two-dimensional space, which is you take the set of real number vertical and the set of real numbers horizontal. So this ones you call it x, and this ones you call it y. Generally, this is what you are used to in high school. However, depending on the value here. So let's say if I ask you to sketch g of a, I say solve. I can literally ask you to solve g of a equal to -1, right? So if I ask you to solve g of a equal to -1, how would you solve it? So you have several options. One option is to sketch the graph of g. Basically here, what am I saying? G of a, g is the function. G of a is the function g, right, at a, and equal to -1. -1 is another function which is called the constant function. So generally, the easy way to do is you take when the g is on the y value. So basically here, for you to solve, you must know that this one is actually the y value. So if you take g of a equal to -1, you must try to think that y equal to -1. So that value is supposed to be on the y-axis. So if I want to say, okay, in the y-axis, this is -1, then this is the graph -1. So that's what it means, is I'm taking the graph of g, and then I'm comparing it to the graph of -1. The graph of -1 is just -1 all over. For any value of x, y is always -1. When x is 0, y is -1. X is 1, y is -1. X is -1, y is -1. X is million, y will be -1. So it's the constant function, it won't change. However, the g of a, is the function where change. So you can call it g of x if you want to. So you see at a equal to 0, you will see that g of a is also equal to 0. That gives you one intercept, right? However, at a equal to -2 is 0. So that gives you the second intercept, right? So basically, you already have an idea. So which means that one intercept will be as 0, The next intercept is at minus, so in the x value. So is at let's say -1 is there, -2 is there. And then the second one is you try to look for the turning point for this graph. So generally, why I did the first principle is for you to have an idea of what the turning point. You take, let's say, g of a plus h minus g of a divided by h, and you try to see how is that one going to look like. So it's generally called a turning point. Now another way of let's say another way of you figuring it out, that so you see the graph actually passes via this, passes what you call via this point. So you have two options. One way you say you can solve it in this way. One way you can say, okay, that is one way to draw the graph of -1 and the graph of g of a. Another way is you take g of a equal to -1. It implies that g of a plus 1 equal to 0, but g of a is a squared plus 2a plus 1 equal to 0. So when you look at it in this way, the new graph, if you take it back to the remarkable identity that I just said, is a plus 1 squared equal to 0. So in a way, it's just a plus 1 equal to 0. A plus 1 equal to, sorry, a plus 1, but I wrote a equal to 1. A plus 1 equal to 0, or you write it as a equal to -1. Right? That's another way of looking at it, right? And then if you pop in, let's say, if you come here, you want to sketch the graph. So you see, if you want to solve, let's say, g of a equal to -1, basically, what does it mean solve g of a equal to -1? Another way of writing it is that find the value of a for which g of a equal to -1, if you want to look at it. So when you get a equal to -1, you substitute this inside. So verification, g of -1 will be -1 squared plus 2 times -1, right? That is going to give us -1 squared is 1, plus 2 times -1 is -2, and then the answer is -1. So g of -1 is indeed -1. That gives you for a equal to -1, g of -1 equal to -1. That's the algebraic option, which is usually the easiest way. For you to solve this, you don't need to follow this technique. You can use the quadratic formula if you want to. So at home, then I'm going to give you another